So I really hope that you've started working on memorizing that list of main players' functional groups because they are important. Why are they so important? Well, in organic, we're all about reactions and what happens when you add this and this together, what do you get? In order to know what reactions happen, we need to recognize functional groups because functional groups, molecules, behave the same way most of the time, regardless of the rest of the structure. So this functional group in this molecule, I hope you recognize, is an alkene. And you don't know this yet, but when you add an alkene in with hydrogen gas and platinum metal, you end up making this thing. What is this thing? It's an alkane. That's one of the reactions we will learn later. You're not needing to know that reaction right now. I'm still trying to convince you that functional groups are important. So that's a simple alkene becoming an alkane. Simple alkene becoming an alkane. What do you suppose happens in this big giant molecule? Well, if you play detective for a second, this is not an alkene. What is that functional group? It's an alcohol, but this is an alkene. So I hope that you can recognize that's an alkene, and therefore the product of this reaction should be an alkane. That position right there should no longer have an alkene. It should have a single bond, not a double. So we will learn a lot of reactions with small molecules like this in simple molecules, but then we will need to be able to apply them in big molecules like this. When there are multiple functional groups, as in there's a bunch of alkane carbons already in this thing, there are alkene carbons, an alcohol functional group also. So let's go through and play detective on some bigger molecules. This is testosterone. He has a few functional groups. You need to identify them. I'm going to make you identify them for some bonus points, but I will also identify them for you. That up there, what is that? That's an alcohol. This one is another functional group. That's an alkene. And this is a ketone. Testosterone has three main functional groups. Sure, all of these other carbons could be called alkane carbons, but we don't generally label those as unique functional groups when there are other things present. We won't talk about this much in here, but this 6-6-6 5-membered ring fusion like that is a steroid. You'll see a lot of those in biochemistry because they're a lot of biologically active compounds have that steroid setup. Okay, here's an antibiotic. What functional groups are found in this antibiotic? You should pause and look for them before I reveal that this is an ether. Are there any other ethers in this compound? Yep. All of those are ethers. What about that compound? That's an ester. Any other esters? Those. I hope you identify them. Codeine, you've heard of it. It's a pharmaceutical thing also. What functional groups are in codeine? Again, please pause and try to detect these on your own, but together we'll talk about them. That's an amine, A-M-I-N-E, amine. This is an alkene. That's an alcohol. That's an ether. That's another ether. And that's a benzene / aromatic ring, all the same so far. Whew, here's a big one. This is Taxol. Taxol has a lot of functional groups. So you should stay paused for a long time while you detect all these on your own. But here they are. This guy is an alkene. This is an alcohol. Any other alcohols in this molecule? Yep. This one, that one, that's all. How about that? That is an ester. More esters? Yep. Here and there. 4 esters in this molecule. What about this? What the heck is that? This pH means benzene. So that means dangling off of this Taxol, we have a benzene, an aromatic ring, where this is the rest of the Taxol molecule. Benzene has several abbreviations. This is 6 carbons and 5 hydrogens, because one of the hydrogens on benzene has been replaced with making the bond to Taxol. So C6H5 is another way to represent benzene, as is a phi, a Greek symbol phi. So this thing and that thing, there are 3 benzenes dangling off of Taxol. They all have 3 different representations, 3 different abbreviations. Okay. What is this in Taxol? This is an amide, A-M-I-D-E, amide, amide. Anything else that we're missing? This is a ketone. Anything else now? This is an ether. That's recognizing functional groups in large molecules. You've got to be able to do that. We may not see a lot of molecules quite this giant when we do our reactions later throughout the course, but we'll see some big ones that have multiple functional groups, and you need to recognize which functional group should do the reaction that you're considering.